know what's the trig identity in terms of sine squared plus cosine squared is equal to?
1.
I'm going to write that down. That really, really helps us out with these problems. Like the sine squared of t plus the cosine squared of t is equal to 1. True?
Mm-hmm.
So if I hide this, what's the relationship on this vector curve between x and y? Don't you see a circle? Because x squared plus y squared equals 1. You all see that? Because of that trig identity. That's just an observation that we'll make. We could apply at some points, but I don't think it would help us to make a decent curve. So like, oh, it's like this curve kind of has something like this going on between x and y. But there's also a z involved, isn't there? So if this thing's kind of circling around between x and y, what's going on with z? Well, as t increases, the z keeps what? Increasing. Do you know, Brad?
Wouldn't it be like an infinite radius disk?
And what would it do? Because remember, it is a curve. It's a curve, so it's doing this.
Keeps going around in concentric circles.
Exactly, and as t increases, it's just going to keep doing this, right? And it would center right on the z-axis. This would be a curve that just keeps circling around the z-axis. It's a curve. There's a name for it. It's called a helix. This right here, it's called a circular helix. And you and I make a sketch. Just a rough sketch and say what? Well, here's the y-axis. There's the x-axis. You might say, well, I want to plot at least one point. Okay, let's just plot that. Where is that? Where's 0, 1, 0? Right there. Heck, if you wanted to get another point, you could, right? But just go ahead and make a little... Make yourself a note that this is a circular helix. Anybody ever seen a slinky before?
Mm-hmm.
Yeah, there you go. Corkscrew. Corkscrew. Sometimes I think it's nice to see it with the what? With the software, so I'm just going to use WinPlot here. I'll hit the light real quick. We don't have to do this with every curve, but sometimes it is nice to see it happen. And when you can actually get this is WinPlot. Sorry, download it for free. And I'm just going to go in here. Is it picking up? Yeah, I'll just go in. I'm going to type in the parametric
I think I'll
equations.
move this way.
Okay.
Yeah, that's big enough. Yeah.
Excellent. Is that okay?
Mm-hmm.
Oh, cool. Hey, so this is WinPlot. I'm just going to type in parametric equations. What was the x component? Because are the parametric equations of the vector curve. We got a what? A sine of t. All right. What's the y component? Cosine of t. And z is just a what? T. I did notice sometimes if I give this more slices here, like I let t go further out, like maybe out to like 25. It does make it look a little bit better. Then you give a little more division, and you'll see this thing. Now I'm going to just say view axes, just so you can see the x and y and z axis, and just let it swirl around. Don't let those things at the end bug you. That's just the software doing that. But I did want you to point out this thing will just keep doing what? Just all the way around being a circular helix. Cool. And if you want to tip it upside down and look inside of it, it's kind of cool, and you see the what? See what I mean? It's like, oh yeah, this thing is a circular helix. Cool. Hey, well, I'm going to close this out, and this is my next problem, and I'll write this on the board, so you can stay there, and I'm just going to go in here and go parametric. Well, what did I have before? Sine, cosine, and t. Well, what if I put t in front of the sine? Let me close this out, sorry. On the equation, go parametric. What if I put t in front of the sine? I apologize, I want to do three-dimensional space. Equation, parametric, there we go. T times sine of t. All right, and then we'll use t times cosine t. And then z is just going to be that 2. So all I'm doing here, what I want you to notice, is in this scenario, I am now putting t's in front of the sine and the cosine. So I'm just going to put a t right here. This was a circular helix, right? How would this affect our problem? I'll tell you what, it'll still be a helix, although this would be 0, 0 here. And then we'll sketch it there, but I just want you to see something. So, okay, what if we put T's in front of that? Well, it still should be a helix. Does anyone have a sense of this? Right? I love it. They're saying, very good intuition, they're saying, this will just what? As T increases, 1, 2, 3, 4, 5, what's getting thrown in front of these circles? 1, 2, 3, 4, 5. That's making the radius of the circle getting bigger and bigger and bigger. So this will be, the last one was a circular helix. We can call this like a conical helix, right? In our rough sketch, we'll look at it with the software, what should it do? It should maybe start out like this, and then the radius gets bigger, and then what? Bigger and bigger. It's like a conical helix. Cool. Hey, let's see how it looks. Again, I'll just give it a few more slices in there. Here, let's see. I'll give it maybe, here we go, 50, try 150. Maybe this will look okay. Boom, did it look all right? View the axes. Sometimes it just chops it up a little bit like that. That's because I had this thing moved around. There you go. Let's see that thing. There we go. There's the conical helix, all centered on which axis? The z-axis. Cool, so I'll close this out. The next one I don't have to put in here, but I was wanting to help me predict this next one. I'll hit the lights. How about this? Sine of t, cosine, and you know this could have a sine of 4t, and this could be cosine of 4t. And you all agree you still have the relationship, x and y is forming a circle? Put a 4 here. So let's think about that. Before I had a t here, allowed it to what? Keep what? Growing, growing, growing. But in this case, z is always going to be a 4. So what should happen here? We still got that circle relationship down here going on, but z is always 4. So what should happen? Up at z equal to 4, we'll just have a circle. It'll just keep going around and around and around, repeating the path. In the plane, z equals 4. It'll just be a circle path. Cool? It'll just keep repeating that. Because z will always remain what? 4. There's no t to let it what? Increase. And by the way, the radius here wouldn't be 4. The radius is still 1. Because sine of this squared plus cosine of this squared, right, would still be equal to 1. Increase the radius, I'd have to put numbers in front of it. So far, so good? Okay, and one more. What if I got sine of t, I got cosine of t, then you got sine of t. Now, everyone, this doesn't have to be a perfect sketch, but we've got to get a sense of what's going to go on here. Now all three have trig functions. Well, let me hide this. Can you first tell me about x and y again? What's the relationship? Between x and y, don't you have a circle again? Mm-hmm. All right. Traveling in this circle pattern between x and y like this. But then this z component is now a trig function. Trig functions are periodic, aren't they? So while this thing is doing that, what I'm saying is this, ready? X squared plus y squared does equal 1 in this problem. Do you all agree? Mm-hmm. Always. So this travels on a cylinder, is what we're saying. This curve must travel on a circular cylinder. This graph right here, it's a function, but it must travel on the surface of a circular cylinder. That must happen. We see that relationship. But as it travels on the circular cylinder, different from the others, it's not going to do the what? That circular helix, that was traveling on the surface of the cylinder, right? This is going to make it periodic. So what it's going to do on the surface of that cylinder, just think it's a trash can. It's just going to keep repeating the same pattern like this, going around the pattern. It's going to look something like this. You know, and just keep going up and down on the surface of that circular cylinder. I mean, there's my sketch. But did you want to see it with the software? Let's just see how it looks. Like, well, that's what's going to happen. Because it'll just keep, this is periodic, it keeps repeating, true? As it sits on this what? The surface of a circular cylinder, and it'll just keep repeating that same pattern. And you go, well, let's look at it. Let's just see how that would look. So I'll type this in, what was it? Let's see. Three-dimensional, I'm going to do parametric. How does this look? All right, sine of t, y is what? Cosine of t, and z is sine of 2 times t. I'll add a few more t values, make it increase to like t equals 50 divisions. How about 150? Let's just see how this comes out. There we go. I'm going to view the axes. All right, let's just get over here. There it goes. It just keeps repeating that pattern. Isn't that cool? This is really sitting on the surface of a cylinder. If I tip it upside down, maybe you can see it. It's like, oh yeah, it's just on the surface of a cylinder. That's the cool thing about this. You can twist it and turn it. But that's what's happening there. And that's why I did this, just to give you a sense of that. Cool. When it comes to rough sketch, you can sketch something like this, but sometimes I like to just have you do a matching. Cool. Great.